All right, so today we are going to continue our lessons on vectors, and today we've already learned that vectors are defined by a direction and a distance, and today we learn an application of vectors called the dot product. So the important part to today is we've already learned a scalar multiplication. We already know that is a constant times a vector. The answer to that, and we already have this in our notes, the answer to this was just CA, CB, and that's still a vector. Your answer here is still a vector. That's all changes when we describe dot product today. So dot product, it's not, I mean, it's kind of like a multiplication, but it's a little different. When you dot product two vectors, you get one scalar answer. So you have vector u, you have vector v. The way you dot product, it's literally written with a dot in the middle, and when you dot product them, you're just going to multiply u1 and v1. You're going to multiply u2 and v2. You're going to add the two results. That's what this formula is saying down here. So when you add those two results, you're going to get one constant answer. You are not getting a vector. So let's just look at a quick example here. If we are going to dot product here, I'm multiplying 4 times 2, that is 8. I'm multiplying 5 times 3, that is 15. And the answer to this problem is 23. That's the answer to the dot product. It goes that quickly. All you have to do is remember to be careful with your positives and negatives. So, properties of the dot product. All right. U dot v is the same as v dot u. We have 0 times 0 dotted with any vector is always going to be 0. Notice the difference here. This 0 is a vector. Your answer to a dot product is always a scalar. So just be careful there. Dot product works similar to distributive property. You can dot both. You can either add v plus w and then dot it with u, or you could dot u individually with each vector and then add the results. A vector dotted with itself is the same as that vector's magnitude squared. And then this is the tricky one, because you cannot distribute a constant into a dot product. You can multiply the constant times one of the vectors and then dot product, or you could do the dot product and multiply by one constant, but notice it can be written 3 very separate ways. Order of operations is extremely important in this last one. Okay, so here's a little practice on those order of operations. Here they are asking us to do, and if you're looking in this first problem, they are asking us to dot u dot v and then multiply that times w. So let's work with the u dot v first. If I'm doing that, I need to multiply -1 times 2, so that's going to be -2. And I also need to multiply 3 times -4, that's -12. So total u dot v is going to be -14, but I'm not finished. This -14 is a scalar, and I need to multiply that -14 times w. Fortunately, we have -14 times it by w. My answer to this first problem is a vector, because notice I'm not doing a dot product anymore. I'm taking a scalar and multiplying it times a vector. -14, 28. There's my answer. All right, I did a dot product, and then I took that scalar and multiplied it times a vector. Got a couple options in this next one. First off, let me erase those pieces, start us clean up here. We can do 2 times v first. That means 2v is going to be 4, -8. We did that last section. And now what I have to do is I have to dot u, -1, 3, with 2v. So if I'm going to dot product here, what I will do is I will multiply first. That's -4. I will multiply here as well. That's -24. My answer to this is -28. That is and notice that is a dot product between two vectors, and when you really break it down, that's why your answer is a scalar. So one of the things to focus on today is, should my answer be a scalar or should my answer be a vector? Okay, so let's clear up what this question is asking us, because this is a formula, all right? This formula is found to get the angle between two vectors. So I'm just going to draw any two vectors. All right, let's call that one u. Over here, we'll call this one vector v. What this formula does is it gets the angle between two vectors. It'll get, your answer will always be between 0 and 180 degrees, no matter how you orient them. Even if, like, let's say I called that u, and this down here I called v, your answer would still be an angle between 0 and 180 degrees every single time. This formula works by doing the dot product between u and v and dividing it between, remember, those are magnitudes, right? Magnitudes of u times the magnitude of v. In other words, another way to say magnitude is just the length of u times the length of v. All right. So here is a very good example of how we can figure this out. Cosine theta equals, we are going to dot product u and v. We are going to find the magnitude of u and the magnitude of v on the bottom. So let's do the dot product on the top. That's going to be 12 plus 15. So the top of this fraction is going to be 27. On the bottom, we have to do some magnitudes. So if I'm going to find the magnitude of u, remember the magnitude formula was 4 squared plus 3 squared, and I take the square root. That ends up being the square root of 25, which is just 5. So I know I'm going to have over 5 times another number. I need to find the magnitude of v. And that's going to be 3 squared plus 5 squared. I take the square root. And that's going to be 9 plus 25. That's the square root of 34. So 5 radical 34. That's really the bottom here. Now, I do not need to rationalize that, because if I take what I've really got here, I have cosine theta. Cosine theta equals 27 over 5 radical 34. And to be able to solve that for theta, I will be using a calculator, and I'll be using cosine inverse. So I got my calculator up here, and what I need to do is I need to type in 27 divided by 5 radical 34. So, well, you have a couple different ways to do this. 5 times the square root of 34 is a good start. 27 divided by that number that I just got. Good, and this is where I want to take my cosine inverse. Cosine inverse of that answer. I'm in degree mode, so my answer is coming out here in degrees. That angle has 21.17 degrees between u and v. 22.17. So we could say theta equals 22.17. Given any two vectors, you can find, using this formula right here, you can find the angle between those two vectors every time. What I'd like to do now is actually expand upon this formula, and I hope that you agree these two statements are 100% equivalent, and the reason is all I did to this side is multiply by the magnitude of u and the magnitude of v to both sides. All right, and this is the same as what's right over here. So I hope you agree that these two statements are the same, because I want to focus on this statement over here on the right. And the reason I say that is now I want to know, we know enough about theta to say what value of theta is going to make the right side equal to 0, because all I have is multiplication, multiplication. So my question is, the cosine of what equals 0? And you should know that because it's on our unit circle. You would say, hopefully 90 degrees and 270 degrees, although we're really focusing on 90 degrees. If the angle between u and v is 90 degrees, then if this was a 90 right here, if this theta right here was 90, then this whole piece is going to be 0. 0 times the magnitude means the whole right side would be equal to 0. It means what must the dot product of u times v also be? Must also be 0, which is where we come up with a very important statement about dot products. All right. if u dot v is 0, then the vectors are orthogonal, and a nice way to think of orthogonal is perpendicular. That's something you've heard before, a 90-degree angle. That's if the dot product is 0, then it is a guarantee that the two angles are orthogonal. Or if you don't like orthogonal, perpendicular would work well. We looked last section at finding parallel lines. Parallel vectors had the same slope to show they were in the same direction. Here we can check, let's see if these vectors are orthogonal. And the way we do that is we dot them, u dot v. And if I dot product, that's going to be 12 plus, I multiply here, that's also negative 12. Because this dot product is 0, it is a guarantee. Are they orthogonal? Yes, they form a 90-degree angle. All right, the angle between the two vectors is 90 degrees. That is all we have on dot product. A short but sweet lesson. I will see you in class tomorrow.